Hello everyone, in this video we're going to talk about proportional relationships and specifically graphs of proportional relationships. So let's talk about it, let's jump in. We got two quantities, x and y. So that's like a coordinate, right? X coordinate, y coordinate, a coordinate point. They are proportional when it satisfies this equation, y equals kx, so k times x, where k is a number and k is not 0. This number k represents what's called the multiplicative relationship between the quantities x and y, and is called the constant of proportionality. Okay, so I know there's a lot of big words in there, but essentially k is the slope of our line, if we think about slope-intercept form, if our y-intercept is 0. So that tells me that the graph of y equals kx is a line that passes through the origin. So we can always tell just by visually looking at a graph if it is proportional if it goes through the origin, and if it goes through the origin, that means the y-intercept, or the value of b in y equals mx plus b, is 0, okay? So there's a couple ways to tell whether quantities are proportional. One is by graphing, or another is actually by dividing y by x. So let's take a look at that. So if we know that our proportional equation here is y equals k times x, y equals k times x, well, if I wanted to figure out what k is, what could I do? I could solve that equation for k, and I would divide both sides by x. So that x would go away, and we would get y divided by x is equal to k. So if two quantities are proportional, then when we divide y by x, it's going to give us the same thing each time. Now, there's one little caveat to that, and that is if we have our origin point, 0, 0. Well, we know we can't really divide by 0 because that is undefined, and so we will need to keep that in consideration when we are dividing y by x. That point is okay. We can almost omit that point because we know that if our graph is proportional, that point should be included because that is the origin, okay? So let's look at 3 examples and I'll tell you what I'm talking about. Maybe that'll clear that up just a little bit more. So number 1, we have the following coordinates, -2, -6, -1, -3, 0, 0, and 1, 3. So let's go ahead and graph these points, and let's see if the graph goes through the origin, and then it will be able to tell if it's proportional or not. So we have -2, -6, -2, -6. We have -1, -3. We have 0, 0, which is our origin point there, and we have 1, 3. Okay, so if we were to graph these points, it would look something like this. We can tell that that graph goes through the origin, so we would say yes, it is proportional. Okay, but now what if we want to actually figure out what that constant of proportionality is? Well, there's 2 ways to do that, and one is by doing the equation that we looked at just a minute ago. Y divided by x is going to give us what k is equal to, and remember k is our constant of proportionality, also sometimes referred to as the unit rate. So let's look at our values here. So y divided by x, this would be -6 divided by -2, and that would give us +3. -3 divided by -1, and that would also give us +3. Now remember, 0 divided by 0, we're kind of going to omit that one, right? Because we don't really want to divide by 0, so we don't really have to worry about that point because that is just our origin point. And then our last one here, 3 divided by 1, is also 3. So if we notice here, 3, 3, and 3, all of those division problem answers of y divided by x, they were all 3. So we would say that our constant of proportionality in this case would be 3. And notice, when we look at our graph, what point is located when x is 1? Well, that would be this point right here. That is the point 1, 3. Okay, so we can also figure out what k is by looking at the corresponding y value to when x is 1. Okay, let's look at the next example. We have 1, 4, 2, 2, 3, 0, and 4, -2. So let's graph these. 1, 4, 2, 2, 3, 0, and 4, -2. Okay, well, when we look at this graph, we can tell that it is not going through the origin. So just by looking at it visually, we can tell it's not going to be proportional. But let's divide y by x, and let's see if we, obviously, since we're looking at it from the graph, we can tell y divided by x is not going to be the same every time. But let's just verify it in case we wanted to start that way instead of graphing it first. So this would be 4 divided by 1, which is 4. So now our next point is 2 divided by 2, and that is 1. So already we can see that the division problem here, y divided by x, is not the same every time. So in that case, it's going to tell us that this relationship is not proportional. We can even see here 0 divided by 3 would be 0. Negative 2 divided by 4 would be negative 1/2. So all of those are not the same. So that just tells me that this relationship is not proportional. Okay. Next one, x and y. So we have negative 4, 2. So negative 4, 2, negative 2, 1, 2, negative 1, 4, negative 2. All right. So let's draw our graph on this one. Okay, it appears to go through the origin. All right, but now let's check our y divided by x. So this would be 2 divided by negative 4, which would be negative 1/2. 1 divided by negative 2, which would also be negative 1/2. Negative 1 divided by 2, which is also negative 1/2. And negative 2 divided by 4, which is also negative 1/2. So we see that all of those quotients there are the same. And so that tells me, yes, this relationship is proportional. And the constant in proportionality, which is k, would be equal to negative 1/2. Okay, so that's how you can tell if a relationship is proportional, by looking at the graph, and also how you can identify the constant of proportionality.